Friends, in our last class, we studied relative stabilities of cycloalkanes, and today we are going to study the angle strain theory. This is used to explain the relative stabilities of cycloalkanes. This is proposed by Adolf von Baeyer in the year 1885. So the theory is based on the classical Liebel and Van 't Hoff's theory, which states that four valencies of carbon are directed towards four corners of regular tetrahedron. So the bond angle between any two bonds is 109 degree 28 minutes. This is according to Liebel theory. But in Bayer strain theory, he explained that any deviation of bond angles from normal tetrahedral angle means 109 degree 28 minutes. Deviation of this angle incurred during the formation of cycloalkanes would impose internal strain in the ring. So this is Bayer strain theory. So we can define it as the four valencies of carbon are normally directed symmetrically in space, making angles of 109 degree 28 minutes with one another, and a deflection of these directions produces strain in the molecule. So this is Bayer's strain theory. So the postulates of Bayer strain theory. The first postulate is the bond angle between the adjacent carbon atoms of a ring no longer equals to tetrahedral angle 109 degree 28 minutes. So when the carbon atoms constituting the ring lie in the same plane, and hence all the cycloalkanes are planar. But consequently, the bond angle between the adjacent carbon atoms of the ring no longer equals to the tetrahedral angle. This is the first postulate. And next one is an internal strain in the molecule. We already explained that there is a produces strain in the molecule. So this strain in the molecule which makes the molecule unstable, thus induced strain is called angle strain. What happens? The deviation of the bond angle from normal tetrahedral angle means 109 degree 28 minutes during the formation of ring produces an internal strain in the molecule which makes the molecule unstable. So here angle strain we can define it as the half of the difference between tetrahedral angle and the observed bond angle. So that is nothing but angle strain. So third postulate is greater the angle strain, greater is the instability of the ring. When the angle strain is increases, there is a instability also increases. Higher the stability of the ring, greater would be its case of formation. So these are four postulates of Bayer strain theory. And next part is here. This is an example cyclopropane. This is the structure of cyclopropane. So here the bond angle between any two carbon-carbon bond means, so this is one carbon-carbon bond and this is another carbon-carbon bond, and the bond angle between these two carbon-carbon bond is 60 degree. Here we can see 60 degree. But our Liebel theory explained that the normal tetrahedral angle must be 109 degree 28 minutes, but in cyclopropane the bond angle is 60 degree. Here what happens, the normal tetrahedral angle is compressed to 60 degree. So here the two bonds are compressed. This is 109 degree 28 minutes. This is normal tetrahedral angle and this is cyclopropane angle. So carbon carbon two bond carbon carbon bond angle is 60 degree. So here we can calculate angle strain. Here angle strain formula is 109 degree 28 minutes minus observed bond angle divided by 2. So already explained that half of the difference between normal tetrahedral angle and observed bond angle. So this is 109 degree 28 minutes is normal tetrahedral angle and 60 degree is observed bond angle. This one is observed bond angle. So the bond angle strain is 24 degree 44 minutes. So there are some example here. This is cyclopropane. The bond angle is 60 degree and angle strain is 24 degree 44 minutes. Similarly, cyclobutane, the bond angle is 90 degree, angle strain is 9 degree 44 minutes. Here this is cyclopentane, cyclohexane, cycloheptane and cyclooctane. So bond angle respectively 120 degree, 129 degree, 139 degree. Similarly, angle strain is minus 5 degree 16 minutes, minus 9 degree 33 minutes, minus 12 degree 46 minutes. So here the positive sign of bond angle the positive sign of angle strain indicates that bonds are compressed like this. Bonds are compressed here from normal tetrahedral angle, and the negative sign, this negative sign indicates the bonds are stretched from normal tetrahedral angle. So in the both the cases the molecule is strained and hence the magnitude of angle strain determines the strain in the molecule. So this is example for Bayer's strain theory. And here next point is advantages of Bayer strain theory. The first advantage is cyclopropane, cyclobutane are more reactive because here cyclopropane, cyclobutane have higher angle strain, hence they are more reactive. And second is cyclopentane is the most stable one, and here angle strain in cyclopentane is minimum, hence it is the most stable one. And the last advantage is the relative stabilities of cycloalkanes up to cyclopentane can be explained satisfactorily. So, relative stabilities of cycloalkanes from up to cyclopentane explained by this Bayer strain theory satisfactorily. These three are advantages of Bayer strain theory. Similarly, next one is limitations of Bayer strain theory. Here the first limitation is higher cycloalkanes are found to be more stable than cyclopentane. Here he explained that cyclopentane is most stable. But what happened? According to Bayes strain theory, cyclohexane is less stable than cyclopentane. Correct? But cyclohexane, cycloheptane, cyclooctane or any other higher cycloalkanes are found to be more stable than cyclopentane. This is first limitation of this theory. And next one is the theory proposes planar model to all cycloalkanes. This theory proposes planar model to all alkanes. Only this theory explains the planar model of the organic molecules, not other. And the last limitation is carbon-carbon double bond is easily formed, but according to this theory, it is very difficult to form. So these three are the limitations of Bayer strain theory.